last method is called Hess's Law, okay? And this is really probably the best example of delta H being a state function, okay? And it's because we can use, if we are trying to figure out the heat of one reaction, but let's say we don't have any information to do it, but we have several other reactions that we could get to add up to this reaction, then we could calculate its delta H. Okay? Now, I was kind of sneaky and I had us write a bunch of reactions so that we could practice heat of formation. And we're going to use these reactions, but you could use any reaction. They don't have to be heats of formation. They could be the combustion of other things. Okay? They could be heat of formation. They could be all sorts of different reactions. As long as you can get everything in the reactions that you're going to use to either cancel out or add up, if you get the exact reaction, then you can add up the heats and get the exact heat. Okay? Sean. Can someone wake up Sean? Okay. All right. So here we go. When you want to do this, the strategy, the easiest strategy is to kind of target each of your molecules. But I will tell you, I'm not going to target oxygen first, because look at how many reactions have oxygen in it. A ton. I don't know which one's the best to use. But if I target this one, how many reactions has it in it? One. So I'm going to target the ones that, out of a bunch of reactions, I can totally pick out the ones that I have to use. Okay? And there could be reactions in your list that you don't have to use. All right? So let's start out with C2H5OH. Okay? I see it only right here. So I'm going to use that reaction. But what I notice is, in this reaction it's a product, but in this reaction it needs to be a reactant. What can I do to this reaction? I'm going to reverse, I'm going to flip it. So I'm going to write it down again, C2H5OH. I am going to have to pay attention to the states of matter. Yields 2 carbons, right? That's going to be solid, graphite, blah, blah, blah. Okay, I've got my 3 hydrogens, and I've got my 1/2 oxygen. Now, what is going to be the heat of the reaction if I flipped it?
Positive.
Same number, but positive. So this is going to be a plus a 277.7. Okay, so I've got this checked off. Yes, I have some other stuff with it, but this is what I care about. Okay, so now, oxygen I'm going to wait on. Let's find the CO2. Do I have a reaction that has CO2 in it?
Yeah.
Yes, and only one. That actually is nice, because I can choose my reaction easily. Is CO2 on the correct side?
No.
Yeah.
Yeah.
Product. So yeah, that's good. Do I have enough?
No.
No. So I actually need to make 2 moles of CO2. So I can use this reaction and just multiply it by 2. So I have 2 carbons, 2 oxygens, making 2 CO2s. What do you think I have to do to my delta H value?
Double.
Just double it. Okay, so now this is going to be negative 393.5 kilojoules times 2. I'm going to wait and do all my calculations at the end. All right, so I've got my CO2. Now let's look for water. You see any reactions? Yeah, and only one again. That makes it kind of easy to choose. So I'm going to use this last reaction. Yes, ma'am?
That's supposed to be positive. The second delta.
No, because I didn't switch it.
Okay.
Right? I kept it the same direction, but just doubled it.
Oh, okay.
Okay? So now let's look at the water. What do I have to do with my water?
Triple.
I have to triple it. So I'm going to have 3 hydrogens, and I'm going to have 3 halves oxygen. It'll work out, I promise. Yielding 3 waters. And Summer, help me out. What am I going to do to my heat? I'm just going to triple it. I'm not going to change the sign. So I've got negative 241.82 times 3. Okay? So I've got my water. Now, let me get my oxygen. But, ooh, I've got a lot of oxygens in there already.
Which one did we use?
Maybe it'll work out. Because, like, if I put this in, is that going to help me?
No.
It doesn't do anything. So, actually, let's see if it works out. I'm going to add up my equations. I'm going to do this like math and simultaneous equations. If there's anything that appears on one side, on the right side, and on the left side, I can cancel it. If there are things that show up on the same side, I have to add. Let's do the canceling first. Do these 2 carbons, look, there's 2 carbons here, and there's 2 carbons here. Those can cancel, right?
Cancel.
So those are out of there. Good thing, because carbon's not in there. All right? How about these 3 hydrogens?
Yeah.
Here's 3 hydrogens here. There's 3 hydrogens here. Get those out of there. All right? Oxygens. This looks gross, but here's a half of an oxygen,
And there's 2.
and here's 3 halves of an oxygen.
So then you just have
2 halves, right? 3 minus 1 would be 2 halves.
1.
And isn't 2 halves the same as 1?
But 3.
Okay, so watch this. 2 and 1 makes 3 oxygens, and that's what I needed. Good. Okay? Let's see, anything else? So I got those. The C2H5OH is here. And then there's 2 CO2s left, and 3 waters left. I have gotten my exact reaction.
Nice.
You have to get the exact reaction, but that is nice. And so now I'm going to add up all my heats. Y'all tell me what you get. You should get something similar to what we've been getting all along.
Wait, so